Hi everyone, thank you very much. So my name is Sebastián Garcia. I'm the director of the Stratosphere Laboratory here in the Czech Technical University in Prague, Czech Republic.
Hello everyone, I'm Kamila Babayeva. I'm a student in Czech Technical University and I'm also a researcher in the Stratosphere Lab. So today we were going to talk about protecting mobile devices from malware attacks using Python intrusion detection systems. So what is the problem? There are a lot of malware attacks on mobile devices, and I think one of the worst is remote access Trojans. And it's really up-to-date problems, right? So we were searching the news and we found the news from 3 weeks ago about remote access Trojans attacking military services, attacking bank accounts, using Telegram channels. And it's all modern, right? And it's very challenging task to detect these remote access Trojans. Why? The main reason is that we don't have a good idea of what is happening in the network traffic of our mobile phones. We don't have a good visibility of the network traffic in our phones. And moreover, we don't usually use antiviruses to protect our phones from malicious APKs.
Yeah, and it's super important to remember that even though rats are old and everyone knows them, it's not so known that a lot of attacks are using them nowadays. We know that a lot of different attacks from ransomware to banking problems are using rats now as their main tool. This is why it's still so important to detect them in the network.
And in order to approach this problem of detecting malware attacks in the network traffic of our mobile phones, we decided to create a dataset of network traffic from Android devices executed with remote access Trojans. When we created the dataset, we will analyze this network traffic and we will implement the detection using our intrusion detection system called Slips.
So this is the first part of our research, that is to create the dataset for the community. Without a good dataset, it's not clear how we can detect these rats in the network. And there are no good datasets about rat attacks, so this is our first contribution.
Our dataset is called Android Mischief Dataset. And as I said before, our dataset contains network traffic from mobile phones executed with remote access Trojans. Currently, we have published our first dataset, our first version of our dataset, and it contains 6 executed threats and 6 network traffic from the phones. But first of all, let's talk about how rats communicate in the network. So in general, we have 2 sides in our rat application, in our rats. The one is the client and the one is the server. The client is the attacker, the controller, the one that attacks our targeted phone. And targeted phone is called server and it's a victim. So the client side, it has a rat application package and it has rat software package. And in this package, we have 2 parts, graphical user interface and the builder. Graphical user interface, the controller, it's where you perform actions to our targeted device. And the builder, it's where you build Android application package for the victim's device. In this Android application package, we have 2 parameters, client IP and client port. And using these parameters, our victim device will be connecting to the attacker. It's important to notice that the client should have public IP and port. It should be public so our victim device, our phone, can connect from any network to our client. To create our dataset, we have created a methodology that consisted of 4 steps. The first step is the installation. The second step is execution, next traffic capture, and dataset login. In the first step, in the installation, our tasks were to find the rat online, to find the rat package source code so we can install it in our machine. Then we have to prepare the machine, the virtual machine, to run the software package on it. And it's a very complicated task because each rat, they have different requirements, different operating system, different plugins and packages installed. So it was very time consuming to find what requirements it should have. It's not usually written in the README for some reason. And the other thing, we should prepare the Android virtual emulation or to find a physical phone that has a specific Android version, because not every rat supports Android version, for example, from 4 to 10. So we have to find the specific version of Android. After we have installed the rat application software, after we prepared our machines, the next step is the execution. This is where we execute our rat controller. This is where we build Android application package for the server. And this is where we perform the actions from the client and the server to the server and back. When we are performing the actions, for example, like take a screenshot from the phone, get the location, get the IP, we are capturing the traffic. And in our dataset, we capture the traffic using 2 ways. The first one is the emergency VPN, and the second one is capture the traffic on our interface. Emergency VPN, this is VPN we use in our lab to capture the traffic on the phones. And an interface we're using from virtual machines, and we're using it because there was a rat that was detecting was not working with VPN together. That's why we switched to interface. So when we're performing actions, we are capturing the traffic. After we are done performing all the actions from the client, we are preparing the rat for the dataset login. We are preparing specific files that each rat should have a dataset. So we have a structure in our dataset, and user of our dataset can understand what this is about and don't have any question about what is happening in there. I'm sorry.
Yeah, I wanted to say that we remember that the importance of having this data set is that it should be curated like this, right? Camila is explaining each step of the methodology because it's super common to have a lot of data sets, but when you go there and you will try to analyze them, you don't know how they were created, you don't know who created them, which conditions, which network, and then different techniques are using different features and then having different results. Specifically for machine learning, it's very important to know where this data is coming from or how it was created. Once you have this curated data set, it's much easier to do and to have correct results. In particular, the important feature of this data set is that Camila executes a lot of real actions in real devices with real rats and using each of the inside parts of the controller, right? Like read files and read SMSs. And then she was logging each of these actions in real time. So you can go to the packets and find exactly what was sent when she was clicking in download a file or download a picture, right? And this is very important for a lot of research that is being done right now. Yeah.
So in our dataset, each rat has 5 types of files. Those are log, packet capture, screenshots, readme.md, and APK. The most important one, as Sebastian said, is the log. In the log, we keep record of what actions we did on the client and the server and what specific time we did. It's important because we can map all our actions in the packet capture, in the screenshot, so we have all mapped and a clear picture of what is happening in the traffic, right? The next file is the packet capture. This capture we did on the victim's device. So you'll see the network traffic from the phone. The next one is a screenshot. Screenshot is a folder, and we took a screenshot of the client and the server when we performed each action. So you can find all the actions and the screenshot for them, how they look like in the controller. The next one is the Android application package. APK, this is the one that was built by the rat builder. We didn't reverse engineer it, so we gave it to our users of dataset to do that, and maybe they're interested in it. And the last one is a README file. In the README file, we put the details about rat. We put the name of the rat. We put the source where we have downloaded it from. We also put the initial status of the phone and the controller. We put details about the packet capture. We put the IP of the phone, IP of the controller, and we described files in there and how the capture was done.
The important difference with other rat executions that you can find is that these were completely controlled by us. So having control of the command and control around the phone allow us to really decide how to attack and when to attack. In other RAT executions that you might find pickups, it's a RAT that is connecting to a command and control that is down. So other network captures that you can see in the internet are not enough to train really on a RAT execution, right? How to see the human taking these decisions and saying, okay, now I'm going to be enabling the keystroke or the audio listening, right?
Mm-hmm. And also in our dataset, we don't have only like malicious traffic. We can see the initial connection of our phone to the RAT. So you can see that we have like a normal traffic and then how the phone is connecting to the RAT using which port, using IP, and using which protocol. Those are examples screenshots of the RAT called HITB. On the first screenshot on the left, you can see a screenshot of the action get location. So this get location we execute on the controller, and we can see the exact location of our victim. This is blue figure on the picture.
Marker.
Blue marker. The next screenshot, second screenshot, it's a screenshot from the phone. In the first message, you can see, hi, how are you? This is actually the message that we sent from the controller using the victim's phone, and we send it to this French number. And on the last screenshot, you can see a screenshot from the phone, and you can see that there are files in there, files example and photo x2. This is the files that we put from our controller to our victim device.
Mm-hmm. Something that we didn't mention yet is that one of the reasons to have this very perfect logging of all the action is because the phone, it's a real phone, which means that it's doing other normal actions on the network. So when you start the phone is connecting to Android, to Facebook, to whatever applications you have in there. And on purpose, we let these applications generate traffic. So when you open the pickup, the first thing that you will see, it's actually not infection. It's a real phone, an infected phone. And then at some moment in time, Camila is putting, hey, this is the moment I start the infection. And this is when the RAT is working at the same time that the normal phone. So for you and for any tool, the challenge, it's not just to detect each of these pickups as a RAT infection, but actually to say, hey, in the first part of the RAT of the pickup, there is no infection. So your tool should say, no, this phone is okay. Then your tool should say, oh, yeah, here there is an infection. And then later on, all this time that the RAT is working, you'd say, yes, there is an infection. So there is a difference between this dataset that is a real phone compared to a dataset where you only have the malicious traffic, right?
Yes. So about our dataset, what RATs we have executed already. Right now, we have 6 executed RATs in the dataset, and the 7th one, we found a bug in the capturing of the traffic, so it's in process and will be published a little later. So current executed RATs are HITB, Hawkshaw, DroidJack, Android Tester, SpyMax, AndroRat, and the one that is in process is called cfco. And each of the RAT in our dataset, it has this set of files, APK, pickup, log, screenshots, and README. So about these RATs. From the 7 executed RATs, actually 3 of them, they were paid RATs. So if you go to the website, you have to pay to use their RAT software package. And they cost usually more than $200. And even there was one RAT that cost $500, which is crazy. But in our dataset, we used cracked versions and leaked versions with password, so we didn't pay anything. And for the RAT Hawkshaw, which is on the cloud, we used the trial version, which is available only for 2 days. So almost all the RATs, they have a local controller, which means that when you install the source code, you execute the controller of the RAT in your machine. But for example, the RAT called Hawkshaw, it's deployed in the Firebase. It's a platform where you develop websites and web applications and Android mobile applications. So it was deployed there, and it was offering a trial version for 2 days where you can try the RAT and then you pay for it to continue it using. So as I said, most of the rats, they were locally in our machines, and most of them, they were using local databases, which means that when we are retrieving the information from the phone, the retrieved information is saved in our machines. But again, for the rat hawk show, when you retrieve the information from the phone, it's saved in their cloud database, which means that the hosts of the
all the victims, right?
Yeah, are saved there, and everyone who has the access to the cloud, it can read all the data. Also, same happened with the rat called cfco. It has a database also on the cloud, and again, everyone who has an access to the database can steal the data from other victims.
Yeah, and the two things that I really find interesting in this is, first, why 7, right? So why we don't have like 100 rats execute? And actually, the interesting part is that there are not many Android rats that you can find right now online. And this is kind of critical. We know that they're being used a lot, but the amount of rats that are kind of supported and that you can really download and you can really install and you can really compile correctly and they are working in the latest Androids, there are not many. That's super interesting because in our mind, when we started the research, we were expecting to find 50, maybe 70. And when you go to the forums and you really want to make this work, we are not talking about the source code. We're talking about making this work. There are not many that are working. Even for them, even if you have the money for Android, there are not many. So this took a lot of effort and time to make it work. And that's why we are releasing for the community. The second thing that I find interesting that Camila was saying is that two of these rats are in the cloud. This is kind of crazy. It's like a different business model. Now you have all the victims of all the people in the same database, and somebody has access to that, like the owner, but also maybe the ISP, maybe the hosting provider, of course, maybe the government if they can access the machine. So this is very risky, but it's much easier to use this rat. So in the cloud versions, you don't have to install anything. You just pay, you download the APK, you give the APK to your victim, and then the victim connects to the cloud, you go to your web page, and everything is working perfectly. And the maintenance is easier, the updates are easier. So this is a very easy model to sell to new customers, right?
And maybe a little more about the rat installation. It was hard initially to find the requirements, but the moment you found, you realize that there are like 2 requirements to download specific version of .NET framework and to download a version of Java runtime environment. So it's time consuming, but it's possible to do that. And maybe we can talk a little about the producers of the rats, who is behind the code. So the rats that are paid, usually there are some companies selling this, and the rats that are not paid, those are like normal people on the hack forums introducing the rat to try on the people you love and to spy on children. And I can talk about Android Tester. Android Tester appeared in hackforums.net in 2019, and it appeared as a fixed version of other rat called Spy Node. And this rat Spy Node, when it was in the version 6.2, apparently it had a lot of bugs, and it cost at the same time $500. This one rat that cost a lot of money. And someone from Hack Forum decided to fix it, and it created another rat called Android Tester based on this Spy Node. And now Android Tester is developing separately, and there are still versions coming, like in the March of this year, and they're all for free, and they're working very nicely. And actually, we will do a demo today on this rat. Anything?
No.
Okay. And now we will talk about Slips. This is a machine learning-based intrusion prevention detection system that we developed in our lab.
So remember the reason of this talk, right? We know that mobile phones are much harder to protect, and we know that rats are a huge threat for the community. So we say, hey, let's try to detect these rats. This is what we want. We want something that can detect these rats. And this something, it's our Stratosphere Linux IPS called Slips. This tool is a Python tool, it's a free software you can go and download and use. We have Docker versions you can install and runs in Mac and in Linux. It's using a lot of different detections, but it's not using fingerprints or signatures, right? It's mostly using heuristics and machine learning automation. So what about Slips? Well, we started developing Slips because there were three main problems we see now in the current tools. The first one is there is no visibility on the endpoint. So again, if you have your own computer, especially now that we are in this COVID situation, Schneider was saying in the keynote that yes, this is much worse for you because you are not inside your organization. That was such a good piece of information, right? Like we are not being protected by our network operators anymore. You're at home, you're traveling, you're in a coffee shop maybe, so your security decreases very, very, very drastically. That means that we do not have any more visibility on the traffic of your phones, tablets, and computers. So you have no idea. And in phones, you cannot install, remember, a very good packet capture to see what your phone is doing. So the second problem, it was about no easy detections. So tools like Suricata, like Snort, like Bro, and we have others commercial, they are focusing specifically in attacks to your organization, right? If you see how the people is using Snort and Suricata, usually it's you define a home network, and then all the attacks going to this home network are the ones that are detected more easily, and then you have some things moving around. In Slips, we are focusing in two types of attacks. The attacks that are going to you, but also the attacks that are coming from you. So we want to detect when your endpoint device is infected and it's attacking others. And this is a very different detection of attacks going to you, okay? And the third issue is no adaptations. To adapt to new threats, you usually have to update your rules, you have to download new ones, and even in this case, there are a lot of situations that are not being captured by the most smart heuristics, let's say, right, or signatures or fingerprints. So in the case of new attackers, which means that they are not usually in your threat intelligence database, or new techniques and new ways of attacking, not to mention new ports or encrypted traffic, then it's not easy to adapt. And this is something we want to focus on Slips. In general, Slips is kind of a complex piece of software, not huge, but a little bit complex. So we want to give you here the 6 main features of Slips architecture. The first one is to scale. It's using NoSQL storage database, sharing the channel and the messages between all the components inside Slips. The second one, it's called the profiles. So Slips analyzes the traffic in the network, and for each computer, it's creating its own profile in the network. So it's storing everything it can find about you. Your connections going on, your connections going in, the ports, source ports, destination ports, HTTP, DNS, domains, everything, even the detections, everything is being stored in your unique profile. The third one is the time windows. So remember I was telling you that in a normal operation, you have a computer that is sending traffic that is normal, then you may be infected at the same time. So you have normal traffic plus infected traffic. You never have only infected traffic, right? And then maybe you clean this computer, and so you have again only normal traffic at the end. So to capture these situations, we split the traffic in time windows. And in each of these time windows, Slips is forced to give you a decision. So it's analyzing everything that is going on in one time window, and it's telling you, okay, in this time window, you're fine, nothing happened. But maybe in the next time window, yes, you are infected and you are attacking others. And maybe in the next time window, you are again clean. So splitting in these time windows is crucial to have very good detections that are moving in time. The fourth feature is the directionality. So Slips can get an analysis on everything that the computers are sending. We call it the traffic going out. So you can tell Slips, hey, only analyze whatever I'm sending or whatever my computers are sending, forget about the attacks coming to us, right? So this is a usual case when you are at home, for example, and you don't care who is attacking your router, who is attacking from the outside. Nobody's going to be targeting you, and you're focusing maybe in your IoT devices or the devices in your network. At the contrary, you can also select all the traffic, so you're forcing Slips to make detections in the traffic that is going out, but also in the traffic going in. And this is very important because then we will build a profile for each attacker. So you have a profile for a computer that is attacking you, but maybe is attacking others. So this is a type of visibility that is not common in the current products in companies. To create a profile of an external IP address, and I want to see when this external IP address is attacking my company, maybe during days. So maybe sending some packets today, maybe some packets in an hour, maybe in 3 hours, maybe in 2 days. But if you want to have this information, you can build these profiles for everyone attacking it. The fifth feature is the modules. So to extend Slips, we have a huge modularity. Anyone can create a Python file module, put it in the folder, and Slips is going to read it and execute it directly. We are going to be telling you about modules later. And the last one is the GUI interface. So to see this information, which is a huge amount of information, usually we have a module developed by Camila called Calypso, and Calypso is an interface, terminal interface that allows you to see everything going on inside Slips. So,
about Redis database, as we said before, to store the flows and to analyze these flows, we use NoSQL database, and in our case, it's called Redis. We use Redis database, and why we use it? It's because we can store the flows really fast, and we can access data in our database really fast. And Redis, it supports like multi-thread access. So when you have a lot of modules analyzing the flows, all of these processes, they should access database in the same time, retrieve information, analyze it, modify, and put it back. And Redis database supports that. In the Redis database, we also use the system called PubSub, and the system of channels and messages. So, for example, when there is some detection in the flows, we will publish a message here, there is a detection, go and check it for other modules. Besides, in our database, we're using not only one, but several databases. The one is like an active database. So the moment you execute Slips, you are renewing this database. But also we have a cache database. And in this cache database, we are storing some detections, scores from the virus total, threat intelligence, IPs information. So for example, if you are running Slips today and you have some IP that you're communicating to, Slips will ask their information from virus total, give me the scores virus total, and it will store in the cache database. So for example, if the next day you're communicating with the same IP again, you will not ask virus total again, because now we have this information stored in our cache database.
So let us tell you a little bit about the modules that you can find Slips. I'm going to go a little bit fast for the names, and then if you want, you can go and check how they are working. The first module I'm going to tell you about is the ASN, Autonomous System Number. So we have an offline database of autonomous system numbers that we're updating, and you can see which organization is the owner of each IP address. Then we have a geolocation module that, taking an IP address, is also using an offline database to tell you where this IP is in the world, which country. The next module is called the LSTM. This is a machine learning module that we train. We using a neural network, an LSTM neural network, based on the behavior of the connections in the network. So from all the flows in a connection, we are creating a type of behavioral letters that is specific type of feature of Stratosphere Linux IPS. And based on this information, we are running an LSTM to know how you're connecting to each port. So we are focusing in the behavior, and using this, we can detect a lot of command and control channels in the network that, for example, are super periodic or have a frequency there. The next module is called the timeline, and here we get all the information that Slips knows, and we show a very nice timeline of each line order, so you can see what your computer was doing perfectly in time and where, right? You will see this later. The next module is the IRC module. This is a machine learning module that we train with real IRC communications, like real users, and then malicious IRC communications. And these two, we also have a published dataset, and we train a machine learning model to detect when the IRC connection is malicious, when the IRC channel is malicious, and when the IRC users are malicious. So this is not about detecting IRC, this is about detecting the maliciousness in IRC. The next module is about long connections. This is a very critical module because a lot of malware, including rats, they used to have, or they have, one connection that is very long in time, several days, and this is kind of anomalous. So we have a module that only detects these long connections and tell us, hey, you should check here, right? This connection is too long, probably. The next module is the port scan module. The new thing about this module is that it's working on flows, so it's not working on packets. So it's a module that can detect port scan when you are analyzing flows, both horizontal port scan and vertical port scan. The next module is the VirusTotal module that it's looking up IP addresses and domains in VirusTotal using the API. You can put your own API if you want, like a string, and then you can retrieve a lot of information from VirusTotal that we are using in our data set. The next module is called the Threat Intelligence module. It's a module that we developed to automatically download and update and upgrade every time that you want different threat intelligence feeds on the internet. Right now we have 4 by default because these are the ones that we know, including our own blacklist of IP addresses that are attacking IoT devices. This is a blacklist generated by Thomas O'Hara, and actually he's going to be talking tomorrow here in Hacking the Box about how he developed a module, an algorithm to analyze blacklist in IoT devices. So we are consuming this one, and we are consuming 2-3 more. The next module is the peer-to-peer module. This is a module still in development, but one of our students, Dita, and she actually created a module to have different Slips tools, okay? So you have a network and you install Slips in different places, and they can communicate in a peer-to-peer network. So in the same LAN, you can have Slips communicating and sharing detection information. And there is a trust model because, of course, you don't trust everyone and you trust people and computers with different degrees. So this is a very nice algorithm how to take advantage of the knowledge of others and not trust so much that you can be misguided, right? The next module is the Calypso module. We are going to be showing you this one. Is to see the information in your console. And the last module is the blocking module. It's a module that, depending on the ensembling algorithm inside Slips, that is telling you, hey, you should block this computer. It's going to the firewall of the computer and actually blocking this computer for some time. So now that we have Slips on the table and you have the data sets of rats, let's see some offline detections of Slips and rats, and then let's see some live demo.
Yeah. So first of all, how we detect rats using Slips. Currently, we don't have a specific module that can detect rats, and we're using the one that exists. And we can detect the following features of rats using our intrusion detection system. Those are the heartbeat, threat intelligence detection, long connection, and malicious IRC. So the heartbeat is about when rats are checking if the client and the server are online, and sometimes they're exchanging packets periodically, and using our LSTM module, we can detect this periodic exchange of periodic exchange of packets. The next one is threat intelligence detections. Sometimes rats are using other...
Yes, they're using like IP addresses that are well known to be part of an attack, or they have been used as part of other attacks before. So these are the feeds that we download from the internet, updating every time, and we are using this information to enrich the detection, right?
And we will show those detections in the next slides. The next one is about the long connection. So usually when the rat is performing actions on the phone, they do not disturb the connection. And those connections are usually becoming really long, like 20 or more minutes long. So we can detect that. And the next one, the last one for now, is malicious IRC. There was a rat that was using IRC bots, IRC channels to communicate with our victim. We cannot detect them currently, but we can see them in the traffic. There are a lot. And for some reason, those IRC channels are all blacklisted. So we detected that. And for our offline example, we will show you the rat called cfco. This is the rat that we had problem with, and it's not currently in dataset, it's in process. So it's
but
like
it's going to be?
It's going to be like a review. Right? This is the rat that is actually, you have to pay for it, and it costs $200. But we have downloaded with the leaked version. And we executed this rat on the Windows 7, the virtual machine. And as a phone, we used an emulator with Android version 4. And we will show you how we run Slips on it and how Slips showed the detections and the evidence we found in the network traffic of the phone using this rat.
So this is an example screenshot of Calypso. So Calypso is a Node.js based terminal application. So you can run this in an SSH computer remotely, which is one of the features that we want. You don't need to have a web or you don't have to have any other interface. And to your left, you can see a vertical widget with a lot of IP addresses. These are the profiles of the computers, and you can see a lot of them are in red. That means that they have some detection inside the profile. On top, you have a summary of the autonomous system number, geo-country, and the 4 detections from VirusTotal, right? The URL, the downloaded files, reference files, and communicating files. In the center, you have the timeline. So you can see ordering time, how each flow was detected or was shown in the network. You can see HTTPS connections or multicast DNS, and you can see the inside of the HTTP communications. And in the bottom, you have the evidence, and you can see in this time window what Slips detected about this traffic. So we are going to be focusing on this rat, cfco. And the first thing we are going to show you is that there is a threat intelligence module that's showing detections, and there is a port scan detection module showing detections. These are one of the 2 things that Slips is detecting. The threat intelligence, this is actually not common because a rat should not be using IP addresses that are well known for the community as being attackers. However, this is the rat that is using IRC channels, and it's using not custom homemade IRC servers, but it's using kind of well-known IRC computers. So these computers have been used so much in other attacks that are actually part of many feeds. And this is bad for the rat because it's kind of straightforward to detect it if you have these correct feeds. The screenshot in the bottom that we are showing you, the port scan detector detections justification, is the flows where you can see how the computer that it's infected, it's generating IRC connections to different IP addresses in the port 6667. Some of these flows are established, which means that they are complete and with data, and some of them are not established and empty. So Slips is balancing all this information and saying, hey, this is part of a port scan because it's actually trying to find the port in a lot of IP addresses. This is a horizontal port scan, right?
I can tell you about the rat, how he was doing IRC connection. So every 10 minutes, the rat is updating IRC servers, those IRC channels. So every 10 minutes, I'm pretty sure you will see the port scan of our computer and IRC channels communicating with each other a lot.
Yeah.
Okay.
As a focus on how this was worked inside Slips, you can see that even some IP addresses, the bottom 2 lines that you see in the screen, were detected both by the threat intelligence module and the long connections modules. So this is helping Slips decide how risky this communication is, right? Remember that Slips, it's using an ensembling module, so it's taking all the evidence of all the modules and then at the end telling you, oh yeah, this is something you should be focusing in, or maybe it's not enough evidence to generate an alert, right? So which evidence or what evidence did we obtain from this offline detection of the rat? Well, it's possible to detect it. There are a large amount of blacklisted IPs. This is bad for this rat. It was using IRC channels to communicate with blacklisted IP. This is also bad for the rat. There was a horizontal port scan, and there were long duration connections. Each of these ones individually, it's not enough to say that the computer is infected, but this is why we have all the modules sharing the information. So Slips can tell you, well, if all this happens at the same time in the same hour, then you should focus on this computer, but maybe it's infected.
And now we will show you the real execution of the rat on the phone, what actions it can perform, and then we will show you how Slips detects the rat on the network capture. So let me share. I hope you can see it. Okay, as an example, today we will be showing you the rat called Android Tester. This was the rat that was found on hack forums. This was a fixed version of other rat that is paid, but this Android Tester is on hack forums, it's for free, and the source code is available. So I'm executing this rat in the Windows virtual machine.
The controller. This is the controller. The command and control panel, let's say.
Okay. And here I open it. You can see the graphical user interface. This is the interface of the attacker where you will perform the actions to your victim's device. So now the first window, we are choosing the port, and we will choose the port 1337 because I know that in our network it's open, so we will use that. In this rat, the builder is built in, like in other most of the rats. So we will go to the tab called Tools, and we will click the Build APK. And here you can see the other window. Here you can choose the name of the app you want that will appear in the user's device. But the most important is the DNS info. This is where you set up the public IP, the IP and the port of the client where you want your victim device to connect. So we have to put here the IP and the port of our device, of the machine where we run the software.
In this case, we are running this Windows computer with a rat command and control in a computer with a public IP. That's why we will see a public IP here right in the console.
So if we type the command ipconfig, we can see that our IPv4 address is this one, 147.30.23.237. So we put it in here, and we chose to listen to the port 1337, and we will put also here port 1337. Next up, you can see all the properties. You can choose the properties for your Android application. You can hide it, you can access keylogger, you can deactivate icons. You can also use the permission root super user. Next up is the merging app, which means that you can take the other APK, for example, the Android application, the Android package of some game, and you can merge them together so the user will never know that there was some app running behind your game. And now we will build the Android application package. We will press build. This to execute this rat software package, there were two requirements. One is a .NET Framework version 4.5, and the other one is a Java runtime environment.
Remember that we are building the APK specifically for this command and control, and this is the APK that you want to send to your victim to infect the computer, right? And you need to rebuild it every time that you are changing the IP address or the port of your command and control.
And today we will be putting APK in the Android virtual emulator. You can see it on your left. This is the emulator with Android version 8, and I'm using Genymotion tool to run it. So now we can see that the Android application was created. It's called Client APK. And what we should do now, we should put this APK in the phone. But because I'm using virtual machines, it's hard to drag and drop. So first I will drop it to my computer. I will close these ones. Yes. And now I'm putting the APK in the virtual Android.
Perfect. So you can see, sorry, before clicking allow, can you take that out? Look at this. It's asking for permissions to actually be super user because it wants to do something at super user, and you still didn't give these permissions, but already, as you can see in the command and control, the rat connected and it's infected, which means that not for all the operations you need to be super user, only some of them, right? Oh, very well. Yeah, that's it. Yeah.
So we will allow the super user so we can have more actions to perform. Okay, so our
we're infected.
So our phone appeared in the controller, and we can see that we have this IP address. We are in Czech Republic, and we can see the version of the phone, the type of connection we use, the battery percentage is 99, what the status of our phone, and if you're doing right now any SMS calls. So I will enable here GPS because it was enabled before. So I will put these coordinates in our GPS phone. Our battery percentage I will put on, and I will show you 41%. And you can see it's already changed the battery percentage in our RAT. So it means that they're periodically exchanging information about the status of the phone. So now we can perform the actions. If I right click on the
location,
if I right click on the phone, you can see all the actions we can do using this RAT. And the first one we will show is the location manager, which means that the controller will ask for the location of our victim's device. And you can see those are the coordinates. This is exactly the coordinates we put in the beginning, right? 65 and 28. And for some reason, this RAT, it uses two maps. One is Yandex map, which is commonly used in Russia, and the other one is Google Maps. So we can zoom out and we can see where are we standing, where is our phone is. The next action we will show you is
read file
manager.
Yes.
Before I put some files in my download folder, so which means that if you go to the download folder, if I double click on it, yes, you can see there are two JPEG files, there are two photos, and if I click on it, you can see a preview of this photo. And there are different actions I can do with this photo. For example, I can download it, so I can download it from the phone to my database in the controller. I will close it, but also I can upload files to this to the victim device. So I have this vacation-free JPEG on my computer, so I will upload it to my device, and file transfer completed. Yes. So if I click refresh, it appears here. But now we will check it in our phone. So if I go to my download folder, right? We can see that there is a vacation JPEG that we uploaded from the controller to the phone appeared there too. But you know, we cannot only upload photo, we can also upload some files, right? In our case, we will use a file which is called drug payment confirmation, which means that we can...
Yeah, it's a very interesting way how to implant evidence in a phone. So people is not aware, but it's very easy to make your phone look suspicious if somebody wants, right? So there you go, you have a PDF with a drugs payment confirmation.
Yes, and if you refresh here, you can see it too. But also, I will show you one more action we can do. We can delete the files from the phone. You delete the files, so it's not here anymore. So it was really fast, the RAT appears really fast. The next action we will show you is the contact manager. So I put these contacts in my phone, but I can show you here too.
One of the most important pieces of information that the people want, right? Your contacts and social network, right?
But we also can add and delete the contacts from our phone. For example, we will add, our name will be drug dealer 1, since we start with drug payment confirmation. And we will put here the phone number. I hope it was pulled, right? Let's try to refresh. Yes,
Okay.
if you refresh, it appears here, but let's check in our phone, it appears here too.
So yeah, there is now a second confirmation that you are dealing with runs,
Yes.
right?
The next we can show you is SMS Manager. In the SMS Manager, we can see the SMS that we sent and received in our phone. Yes, let's outbox, inbox. Yes, we can see all those folders in our phones.
Yes.
Okay. The next one, I think the last one we can show, is a microphone. So if I press listen, you should.
There you go. So you can hear there how at the moment, oh yeah, sorry, there was a loop back, so that's why we close it. But when you press listen, there is a delay on time, and then you can see how this is like in real life with some seconds of delay. Yeah, listening to the phone, no problem. Right? Perfect. So now let's gonna check. We have a couple of minutes. Let's show the detections in real time. Yeah.
So now we will show you how the Slips can detect the rat in this network traffic. Sadly, we cannot run the Slips and to capture the traffic from the phone, because as I know that this rat has the evidence of long connection, which means that if we want to detect this rat, we have to run this rat for a long time. So that is why we will use already the capture traffic, and we will run Slips on this capture.
Yeah. So usually when you are running Slips in real time and you wait for an hour, well, then you have the long connection detections, right? In here, yeah, we already have the pickup for this, so you can see. So here Slips is going to be showing you how it's loading the modules and how it's telling you what's going on in each time window. And you already can see that there is a detected IP because of a long connection, and there's going to be other detections later, right? So now if we go to Calypso.
Okay, if you go to Calypso.
There you go. This is the interface. I hope you can see this and it's not too small for you.
As we can see on the left, we have already two profiles. The first profile is apparently the profile of the router, and the second profile is the IP of our device. And in this profile of our device, we have two time windows 1 and time windows 2. And as we can see, time window 1 is red, which means that there were some detections in this time window. So if you click on it, we can see the timeline of this profile. So all the flows that were sent out from our device, you can see it in the middle. And you can scroll it down. And for example, here you can see that we're connecting to Facebook, to Google, to Instagram.
All the normal communications from the phone, right? And in the bottom, in the evidence, you can see one of the first detection that is, hey, there is a long connection to this IP address, which is one of the evidence that you are connecting to a command and control, right? So Calypso has a lot of features around. We are going to be stopping now just to show you very fast that there is a hotkey that you can see a very simplified view of the communications. So in this screen in Calypso, the first column to your left, it's a connection tuple. It's like a flow. So it's like have IP address and destination port and protocol. The next column called string is the behavioral letters that Stratosphere Linux IPS is creating, and they are documented in the documentation. Each letter there corresponds to a flow in the same connection. So you can see there which connections were periodic and not periodic, knowing the letters and the symbols. The third column, the DNS resolution, is about which DNS name was used to resolve this IP address. Then we have the autonomous system organizations, Facebook, Twitter, and Google. And then we have the columns regarding the virus total, the country, and then the four last columns regarding the virus total. You can see the percentage of detections in virus total that has this URL, that has this IP in the URL, that were downloaded from this IP, reference this IP, or communicate with this IP. So you can see there very fast how many detections each of them have. That, by the way, if you take a look, all the detections are in IPs that are well known, like Twitter and Facebook and Google. This is the real case of threat intelligence, right?
So we will stop here for now, the demo.
Yeah. So as a conclusion and ending, You know, rats are still a real threat, very much used for many attacks. This is a reality. Also, that mobile devices have less security solutions available. This is very bad. Third, that we created the Android Mischief Dataset version 1. Is the first of its kind for the community, so go there, download it. We are going to put the link now. And then that Slips as intrusion detection system using machine learning and other types of detections can detect RAG traffic detections in real time, right? So thank you.
Thank you very much. For joining us.
There you have the link of the data set. The password is infected. Also, you can have there the link of Slips, so you can go and detect it. And we are up for questions if you have any.